Welcome Year 12. This is the start of the first chapter, so the course is underway. We've been doing all the work to do with numbers and scale and trying to get your head around the sheer range of which physics does, but now we're starting to get into the nitty-gritty. So, quick heads up first, although this is Chapter 1, they all have a similar layout. Module 2 is going to be in every single paper. This goes across everything, that's why it's the basis of everything. Module 1, which is practical skills, also goes across everything. So both of them will have a blue cover. Doesn't look very blue, unfortunately, in this light, but a blue cover. Now here's stuff you should have done before, GCSE. If you have not seen some things on here, on any of the chapters in that prior learning, then you need to go away and look it up. It's stuff you should have done, you may have forgotten, you may not have done much on it. Okay, we will pick stuff up, but I'm assuming you have this knowledge so that we can run with it. However, the crucial bit is this. It's again on every chapter. This is stuff you need to be able to do, or you need to know to be successful, to really get the grades in this subject. So that's kind of the general layout of everything, and then underneath are things to prepare you for your revision. January of year 13 is when you're starting the build up, the slow build up and the wind up to the exams. Okay, it's a long increase like a dynamo starting up. So you need to be able to pick out from the 24 chapters which bits need the most work, and these are where it's really, really important. So you'll have fairly soon your minimum target grade, the thing that you're aiming for based on your GCSE. Okay, you'll have a percentage, so again that will give you an idea. You're going to self-mark the homeworks, you know roughly what that grade is or roughly what the standard is. And then for the assessments, again, percentage is useful. We'll put the grade as well, but the percentage is more useful because if it's a B, is that a high B or is it just scraping a B at the bottom? So this is kind of a way for you to then go, right, I'm below here, or I'm doing okay, or I'm above my target grade. In which case, if it's below, it needs picking up when you're doing your revision and before that. If it's on or above, then it's not as important as the ones that are below. And then this one's very general because this needs a bit more support, but what I've put here is different topics work best with different types of revision techniques. So some may have flashcards, some it's more about mapping the topic. So whatever's in this box would be useful. But the feedback from the ends, the feedback from your test, the thoughts that you've had about your homework and your test, things that make a difference, things that are really important to remember. Maybe always remember to check that time is in seconds, for example. Those are the kind of things to put on here. So again, when you're revising, you can just go, oh yeah, with this topic, any questions on this topic, I need to be able to do these. Okay, or must remember to use those techniques. So, revision stuff, that's crucial to get you focused in your revision, but all the stuff you need is this here. Okay? So, same with every chapter. Let's dive into this one. Not much in the way of notes, because all of this really is in the PowerPoint. So, go and have a look at the PowerPoints first. They're really, really important because they're going to give you the examples, whereas these are really just the basic ideas. So, you'll have seen from these, you'll have picked them out, everything in physics links together. If we double some effect, like maybe doubling a distance, then you may you'll need to realise that you will need twice as much energy to make that happen, etc., etc. So everything has to join together. But what is a bit more crazy is that everything can be simplified down, and this is really what physics is about, trying to make things really, really simple. So these can be simplified down to one or two key ideas, and again the PowerPoint tells you where they've come from as such, and some of the definitions of them have changed over time, but everything can be simplified in these ways. So the 7 quantities are length or distance, okay, and the unit that we use for that is the meter, okay, and that's RE. because it's not a measuring thing. A meter of unit is RE. We have mass, and the correct version of mass, the acceptable one, is the kilogram. Okay, so that is the SI unit, the System International unit. Chemists use grams because it's more convenient, but the actual units that is recognised around the world and used around the world for everything, not just chemistry, is the kilogram. And then the other big one that we use a lot, all the time in fact, is time. And all questions and all things for it to work must be in seconds. Okay? Because anything under seconds is hundreds, millions, whatever. Whereas, yeah, a bit of an hour, it's much better to say it's in seconds, so it's nice and clear. So those are used all the time. Okay, meters per second squared, distance and time put together to give you an idea of speed. Other things that we need the link in with these and can't be defined in terms of length or time or mass easily, and so therefore it makes more sense to have something pure. Well, for electricity, the one thing that really matters is the current. I know it's made of charge, but actually electricity is the flow of charges, so it's that current that is the key idea that runs through it all, and that is measured in amperes. Okay, that's the correct spelling, because Monsieur Ampère, who did all the work on it, is French and it's an E graph. Temperature, some of you might have done this, some of you might not. Temperature is based on Kelvin. It's not degrees Kelvin, it actually has a 0 value and goes up from there. All the others, like degrees centigrade, you can have -10, can't you? So minus and plus kind of are all a bit relative. This is an absolute value, so 0 is as cold as you can get, 0 Kelvin. And then the last one has a bit of a strange title. It's amount of stuff. It's not the mass, but it's how much you've got. Amount of substance. Okay. And that, to keep the chemists happy, is moles. How many moles there are. Okay. Now there is one more which doesn't link in with these, and that's light. The problem with light is that there's lots and lots of similar units, and they all mean slightly different things. So firstly, to show it's light, we call it luminous. I apologise if this doesn't show up too well, but luminous intensity, so brightness of the light, but it's a certain type of light, which is where the words come in together. And this is based on originally on the brightness from lighthouses, so it was originally in candles. So we still stick with the unit of candela. Okay, now that is not very useful in real life. We tend to talk about lux, which is how spread out that light is instead, so intensity in a different way. So although everything can be converted into candela or from candela, we don't tend to use it. So it's in that greyed out box because you're not seeing the exam. Okay, so it's worth putting in. Also that one. Okay, now we're not in the habit of writing these after every number and every answer, but if we have a number as an answer but without a unit, it's meaningless. So how far have you come? 7. 7 what? Yeah. So rather than writing these, obviously we have the simplified version, which is single letters, and they have to be correct. So not a capital M, but a little m as well, you know. Kilogram. Okay, so both little letters. Seconds. Capital still for amps, because it's or amperes if you prefer. Because it's somebody's name. Capital K for this, because actually it was Lord Kelvin. And mole is simply mole. There is no shorter version for that. And if you did see candle, it'd be CD. Okay, which looks a lot like cadmium, but let's not worry about that. Okay, because it's not chemistry. So great. But sometimes we want to measure bigger things and smaller things, and we can use scientific notation as the videos on scale were hinting at, but we can also use, rather than standard form, it's often quite convenient to use scale that we're happy with. So for example, you might want to measure something in millimeters, and it's still meters, it's just scaled down from meters. So we have these prefixes that go onto the front of all the units, and we use whatever's convenient. These are the ones you'll need for the exam, and they go from pretty big down to pretty small. Okay, and that's the kind of idea with it. So the convenient thing is that when you work out an answer, as it's saying here, if you work out an answer and you push the ENG button, the engineering notation, then what you'll end up with is it will convert it to the nearest power of 3. Okay, so the difference between these are 3 digits. So this is million, million, thousand. So 1,000 million million, or times 10 to the 15 noughts. Okay. Down here we've taken off 3, so it's 10 to the 12. Yeah, so 1,000 times smaller than a peta is tera. So teravolts is a fairly typical thing in lightning storms. Peta is fairly big. When you're getting up to petavolts, for example, you are talking very intense electricity, sometimes done in research for nuclear fusion, for example. If again we go 1,000 times smaller, well, we're taking off another 3 noughts, so that's 10 to the 9. Yeah, and this might be quite useful. I would suggest for you to kind of go through. It's a little bit of colouring in, but you know, just to kind of see how it shrinks down. Mega, again, megavolts, very common, pretty common things. Gigabytes of technology, you know, memory chips, storage ability. Kilobytes, which was the floppy disk that we were using when computers were first coming out, personal computers. So again, I'll get you to fill in those. I'll do one right at the bottom for you, but 10 to the 6, 10 to the 3, and then 10 to the 0. So, because that's 3 down from 3, but anything to the power 0 is 1. Okay, so this could be meters, volts, whatever. Amps, any of those, or it could be other things like Gauss, so you can get a milligauss or a megagauss, okay, things like that. That's magnetism. So we keep going down. So again, 3 down, 10 to the minus 3 has a commonly used name, millimeters, for example. Yeah, and then down from that we've got micrometers, then nano, so nanotechnology. This, in terms of meters, again sticking with that, that's about the size of an atom. So atomic structure, when you're looking at joining atoms and molecules together, we're talking about nanotechnology. So 10 to the minus 9 for that one. 10 to the minus 12, not used a huge amount, but used a lot with electricity. So capacitors are often in picofarads. Farad is the unit for ability to store charge, so picofarads. And then femto is surprisingly common. You might think that's pretty small. Well, again, using that notation there, we've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Yeah, so it's that 15th decimal place down. Now, if you're struggling with that, think of it for all of these as where we move our decimal place from. So here we'd need to move it 15 along to get to here. Okay, so that digit, that first digit, whatever it is, 5, 10, 3, 6, 9, 12, 15. Okay, so you can fill all the ones in between and you'll get that lovely chamfering because it's really growing up in scale. So have a practice with these, get used to pushing that eng button. It's really useful. If you push it again, for example, if you get something times 10 to the 9 and you push it again, it will make it bigger, and so it will reduce the number in front of the decimal place. Push it again, you move up, and if you push second function, eng, it'll move down, okay, every single time. So it's a really convenient way of bouncing between things. You don't have to put them into scientific notation like this. Okay, you can actually just use, instead of saying that, you can say the word instead, and people will know what you're talking about. So we'll leave it there. Short, intense little unit, but really, really useful. And strange enough, all your numbers have a scale. So whatever you're given, you're going to need to use that. Okay, thanks guys.